Check if the screen is visible.
Yes, sir.
Okay, so very good morning, students. We'll continue with our collision resolution technique, which we were discussing in the last lecture. Before we had a break in the last lecture, we discussed that in hashing sometimes we may get collision. Collision is a phenomenon in which for multiple key values we get the same hash value or the same hash address. So in that case we cannot accommodate the new key value in the same location, so we need to find some different location for it. In order to do that, there are different techniques that we discussed. There are two types of collision resolution techniques. One is open addressing and second one is chaining, which are also called as open hashing and close hashing respectively. From which we started with the open addressing scheme in the last lecture, out of which the first type we had discussed, that was linear probing. Okay, so the equation for linear probing is h dash of k comma I is h of k plus I mod n, where h is the original hash function, h dash is the linear probing hash function, k is the given input key value, n is the number of slots available, and I can take any value from 0 to n minus 1. So based on this, we had taken one example in which the value of n is given as 10 and 6 key values we had taken like 15, 23, 25, 24, 16, 78 and so on. So initially we calculated 15 with the value of I as 0, for which the answer came out to be 5. So we stored 15 in index number 5. Next key value that we picked up is 23 with the value of I as 0. So the value of hash address comes out to be 3. So we store 23 at 3. Next key value that we take is 25 with the I value of 0. Now with this we get the hash value as 5, but now as 5 is already occupied, this gives us a collision. So that's why we had solved h dash of 25 comma 1, which further gives me answer for hash value of 6. So we store 25 at 6. Next element that we get is 24. We solve 24 with I value of 0 again. This is one thing which we have to remember, that while picking up every new key value, the initial value of I should start from 0. Only in case if you have a collision, then only we will be incrementing our value of I by 1. Are you getting this? Even if we get one more collision, again we can increment the value of I by 1. But whenever we take a new key value, the initial value of I should be reinitialized to 0. So next time we solve 24 with 0, we get answer as 4. So we store 24 at hash address 4. Next value that we pick key value is 16. We solve 16 with I value of 0. We get answer as 6, which again gives us a collision. So that's why we solve 16 with 1, for which we get hash value as 7. And that's why we store 16 at 7. And finally we'll have key value 78. So for 78, we will be getting answer as 8. For 78, we will be getting answer as 8. And hence, this particular 78 will be stored at the address, hash address 8 or index 8 we can say. So this is how the storage will take place. Now later on, suppose if someone asks you to search key value 25. If I ask you to search key value 25 in this particular given input, because at the end we are interested in searching, right? So for searching also the same mechanism of linear probing should be used with the same hash function. Then only searching can happen. Continuously I am telling you these things, that whenever we do hashing technique, whatever mechanism we use for storage, same mechanism has to be used for searching purpose. So when I say 25 to be searched, then first I will do 25 comma 0. I'll get answer as 5. So there I will not find that number. Then I'll solve 25 comma 1. Here I find that number and my search becomes successful. Now in case of an unsuccessful search, it will take a lot of time for us to comment an unsuccessful search. But in case of a successful search, the time may be reduced in case of hashing, and it can be brought down to near to constant. If your hash function is a perfect hash function, then there will be no collisions, and in that case you can get constant complexities. So I hope all of you have understood this example of linear probing. Shall we move ahead with the second type of collision resolution technique today? Yes, students?
Yes, sir.
Okay. So we have seen linear probing now. So we'll move on to the second type of collision resolution technique today. That is quadratic probing. Second type of collision resolution technique, that is quadratic probing. So the concept lies similar, that you will be getting certain collisions, and whenever you get collisions we need to find some other locations. For doing this we will be using certain mathematical equations, right? So you will be given certain input key values, you will be given the value of number of slots also. So suppose these are our available slots given, so I am taking those slots over here. Suppose this is our given array. So suppose value of n for us in quadratic probing example is also given as 10. Okay, value of number of slots is given as 10. Okay, and we have certain key values for which we are going to solve now quadratic probing. Okay, now in quadratic probing the equation is as follows. The quadratic probing hash function h dash of k comma I, the quadratic probing hash function h dash of k comma I is given as h of k plus c1I plus c2I square mod n. I'll repeat the equation. What is equation of quadratic probing? The quadratic probing hash function h dash for key value k is given as h dash of k comma I is equal to h of k plus c1I plus c2I square mod n. My dear students, now most of the terms in this equation are very similar to that of linear probing, but we also find some new terms in it. So let us see meaning of all these terms. So what all things we know from this? What is h dash? H dash is the hash function of quadratic probing. Okay. What is h? H is my base hash function, my basic hash function. H is my basic hash function. So in this case, my basic hash function is h of k, which is nothing but k mod n, which is nothing but k mod n. What is n, my dear students? N is number of slots. N is number of slots. What is k? K is input key value. What is k? K is input key value. What is I? I is a value which basically we use to control the collisions, which takes value from 0 to n minus 1, which takes value from 0 to n minus 1. So whenever I get value of I as, whenever I take value of I as 0, and if I get a collision, I'll make I as 1, then I'll make I as 2 if required, right? And so on. So the concept of I remains same. Concept of I remains same, that I takes value from 0 to n minus 1. H dash is my quadratic probing hash function. H is my base hash function, which is k mod n. N is my number of slots. And what is k? K is my input key values. And I is taking values from 0 to n minus 1. Now, apart from this, you can see there are two values also given in the equation in the form of C1 and C2. Now, these two values are constants. These two values are constants. These values will be given to you as an input for solving quadratic probing. So this is input C1 and C2. Suppose for example, I take value of C1 as 1 and value of C2 as 3. This will be given to you as an input while solving the numerical. So apart from n, k, now C1 and C2 are also given to you as an input. Okay, so suppose given value of C1 is 1 and given value of C2 is 3 for you people. Okay, now let us take some examples so that this working of quadratic probing will be more clear. So I'll take some examples. Suppose I take key value 24. Suppose I take key value 24. Okay, I'll erase this part. Let us solve now. First key value 24. Okay, so I am solving h dash of 24 comma initial value of I will be 0. Initial value of I will be 0. So this will be nothing but h of 24. Okay. C1, what is C1? C1 is 1. C1 is 1. So 1 multiplied by 1. Sorry, 1 multiplied by 0 because value of I is 0. Plus C2, what is C2? 3. 3 multiplied by I square. So I is 0. So it is 0 square. I is 0. So it is 0 square. Mod n. What is n? 10. So mod 10. What is this h of 24? It is 24 mod 10. It is 24 mod 10. And this terms comes out to be 0. This multiplication terms comes out to be 0 for us now. Because initial value of I is 0. Mod 10. So this final answer comes out to be 4 mod 10. Final answer comes out to be 4 mod 10, that is 4. As it is the first element, it will not find any collision, right? So I store 24 at hash value 4. So I store 24 at hash value 4. Is it understood, students, how this example is solved? How we substituted the value of k, I, and C1 and C2? Yes, students?
Yes, sir.
Okay. Okay. So suppose now I take next key value as 47. Suppose I take next key value as 47. So what will be next thing that I solve? 47 comma 0. 47 comma 0. Okay. So this will be h of 47 into 1 multiplied by 0 plus 3 multiplied by 0 mod 10. So this will be 47 mod 10. So this final result will come out to be 7 in that case. Final result will come out to be 7 in that case, right? So 47 will be stored at hash address. It will be stored at hash address 7. It will be stored at hash address 7. Is it clear, students?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Now suppose I take some collision example so that it will be more clear. Now suppose I take next key value as 44. Suppose I take next key value as 44. So we are solving now. First, as I told you, for every new key value, value of I will start from 0 initially. So we have to solve first h dash of 44 comma 0. See, when you solve this numerical in paper, all these key values step by step you have to solve. You cannot take shortcuts. Okay, what the way I am writing every step, it should be written in that way only. H dash of 44 comma 0, all substitution should be written. Then if collision is there, it should be mentioned. Then only value of I should be incremented. And accordingly, you should build your array and you have to take new key values and proceed in your solution. Okay, so coming back to our example, we are solving h dash of 44 comma 0, right? So it is h of 44 plus 1 multiplied by 0 plus 3 multiplied by 0 mod 10. So in this case now, what will happen now? We are getting result as 4. We are getting result as 4. Now this 4 is giving us a collision. This 4 is giving us a collision. The moment this 4 gives us a collision, what we will do? We'll increment the value of I by 1. So the next thing that I will solve will now be h dash of 44 comma 1. H dash of 44 comma 1. What will be h dash of 44 comma 1? It is h of 44 plus C1 multiplied by I. Now C1 is 1. 1 multiplied by I. Now the value of I is 1. Now the value of I is 1. Plus C2 multiplied by I square. So 3 multiplied by 1 square, that 1 square will become again 1. Mod 10. Mod 10. So this will now come out to be 44 mod 10 plus 1 plus 3. Correct? This 1 multiplied by 1 will give you 1. 3 multiplied by 1 will give you 3. So finally this will be 44 mod 10, that is 4 plus 1 plus 3, that is coming out to be 8. So it will be 8 mod 10. 8 mod 10. Don't forget there is an outside mod 10. Many times students forget this outside mod 10. Okay, now it is okay that your answer is coming within the range of 10. But if this answer increases, then sometimes students forget to write this mod 10 outside mod 10 and they feel that their answer is wrong. Okay, so here answer is coming out to be 8. So now here 8 is empty. So we will be storing now 44 now on 8. Is it clear how did we resolve the collision using the quadratic probing equation?
Yes, sir.
Is it
Yes,
understood?
sir.
Yes. Yeah. So next value, key value I'll give you is 12. So all of you solve it in your notebooks. All of you must be having your notebooks. So quickly solve for key value 12. So solve h dash of 12 comma 0. Right in the, see, we know that the answer is 2, but it should be written with proper steps. So write in your notebook so that it will be easy for you to grasp this thing, right? H dash of 12 comma 0. All of you solve. H dash of 12 comma 0. H dash of 12 comma 0. Solve. I'm giving you 1 minute to solve this. Done, completed. Very simple task, right? H dash of 12 comma 0 is h of 12. So this will become 0 as value of I should be taken as 0. Very important. I hope all of you have taken value of I as 0. This is very important because what I told, for every new q value of I should be taken as 0. What final answer you have got, all of you?
2.
2.
2. 2.
Very good. 2 mod
2.
10, it is coming out to be 2. Very good. So this 12 will be stored at 2. Next, all of you solve 22. Key value 22. Key value 22. So the first thing that you should solve with key value 22 is h dash of 22 comma 0. H dash of 22 comma 0. H dash of 22 comma 0. So what is h dash of 22 comma 0 answer? It is 2. All of you must have got this, right? H dash of 22 comma 0 is 2. It is collision, right? So what, after collision, what you will do? Can anyone tell me? After collision, what you will do?
Increment
Okay.
I by 1.
Increment I by 1.
Increment I.
Very good. We will be incrementing value of I by 1. So we will be solving now h dash of 22 comma 1. We'll be solving h dash of 22 comma 1. Chalo, solve quickly. H dash of 22 comma 1.
6.
Very good. So this, yes, it will come out to be 6. So 6 is available? Yes, 6 is available. So that is not a collision in this case, right? Again, if we get collision, then we'll increment the value of I by 1, right? So the concept remains same. So this value of 22 now will be stored at 6. Is it understood, students, the working principle of quadratic probing? So this will be given to you, number of slots and your key values for solving the numerical will be given to you if a numerical comes in the paper, or you may get theory type of question also that explain collision resolution technique. So in that case, you need to take the values. And with respect to constants, See, constants will be given to you as input, but if they are not given to you as input, you can assume the constants. Are you getting this, right? So suppose constants are given to you, it is okay. You have to take the same constants and you have to solve. But if constant C1 and C2 is not given to you in the input, then in that case you can write an assumption, right? Like assume C1 is equal to 1 and C2 is equal to 2 and you can C2 is equal to 3 and you can solve. You can take any assumption for constants. Are you getting this? So even if they are not given, even if the constant values are not given, don't assume that it is a mistake of program or it is mistake of question. Because in the question paper it is always written make suitable assumptions wherever necessary. So if the values of constants C1 and C2 are not given, you are free to make assumptions for these constants also. But you have to make sure that you declare these assumptions before solving the problem. So if C1 and C2 values are not seen and if you are asked to solve using quadratic probing, your first statement should be assume the value of constants as follows. C1 is equal to such and such, C2 is equal to such and such, and then you can start taking your key values and solve. So the examiner, the one who is checking your paper, will come to know that what constant values you have assumed for solving your problem, because each students will make different assumptions in that case. Is it clear, students? Shall we move on to the next type of open hashing?
Okay, sir.
Yes, sir.
Okay, so let us now move on to the third type of open addressing or open hashing scheme for resolving collision, that is double hashing. The next type is double hashing. All of you just pay attention. So double hashing, again the concept remains same, that it is a technique basically used for resolving the collision. It is basically a technique for resolving the collision. So suppose this is your given slots available for storage purpose. Okay, so I'm taking my number of given slots as 10, and see my dear students, for you to make understand, I am taking value of n as 10, but in the paper you can have any value of n, some different values like n is equal to 13, n is equal to 8. So the mod has to be with respect to that. So be careful in reading the numerical also. Okay, n is equal to 10 initially I have taken so that understanding becomes more easy, but number of slots can be anything. It can be 16, it can be 14. So that calculation has to be made with respect to that division. Okay, yeah, coming back to double hashing, here I am taking value of n as 10. So these are the 10 slots available. Let us see what is the hash function for double hashing. It is h dash of it is h dash of k comma I is equal to h of k, it is h of k plus h2 of k, I multiplied by h2 of k mod n. See my dear students, here we have three hash functions now. We can see that there are three hash functions now. Okay, I'll tell you meaning of all this. What is h dash? H dash is the double hashing function, which is our main collision resolution technique function, that is h dash, which we are doing it for key value k with the value of I. This value of I will be 0 initially, it will become 1, 2 and so on only if there is a collision. The concept remains same, right? So this we all know, h dash of k comma I is basically our collision resolution technique function of double hashing over here. Now inside this what we have? We have h of k. Now we know what is h of k also. What is h of k? It is our base hash function. It is our base hash function, which is k mod n, which is k mod n, which is k mod n. Are you getting this? H of k is k mod n, right? I, what is I? We all know 0 to n minus 1, right? And this mod n outside we also know, n is number of slots. Now what is new here is h2 of k. So this is the second hash function, and that's why this technique is called as double hashing. Okay, h2 is another hash function. What is h2? h2 is another hash function on the same key value, but it may be a different hash function. it may be a different hash function. So I call this hash function as some k mod m. See, h2 is some another hash function. Okay, so I call, but on same key value. The key value that you pass to that hash function is k, for which you are solving the original double hashing function, right? So h2 of k only we are calculating, but it is a different hash function. So I'm taking a different mod in that case. For the base hash function, I have k mod n, but for the second hash function, I am having k mod m. Now, whether it is compulsory to have a different hash function, it is not compulsory, but it may be there. So I'm intentionally taking a different hash function so that we will come to know that h of k is a different hash function and h2 of k is a different hash function. So h of k here is k mod n and h2 of k is k mod m. Now this m can be given to you as input, or you may assume this. N will be given to you as input, n, but m, that is for second hash function. If this is given in the numerical, okay, but if it is not given, as I stated in case of quadratic probing also, you assume the constants. Similarly, you can here assume the value of m also. So for this example, I am taking value of m as suppose 7. I am taking some value of m as 7. Are you getting this, my dear students? Is the meaning of this equation clear? Anyone is having any doubt in the equation, terms used in equation? Anyone is having any doubt? Is it understood?
No.
Okay, so initially, as I told you, value of I will be 0. So when the value of I is 0, then this h2 term will indirectly become 0. This right hand side term, right? So this second hash function will only come into picture whenever there is a collision. This I term gets activated only when there is a collision, right? So if you initially solve k with 0, you are basically interested in your base hash function, that is h of k only. When h2 will contribute in your answer only if there is a collision, and that's why we say this technique as a double hashing. So we are interested in the base hash function only, which is h of k, which is based on our number of slots, that is n. But if it gives you a collision, then we know that there is a term I which we increment. So when we increment this I, some contribution from h2 will also come into my answer, because I will be doing 1 multiplied by and 2 multiplied by and so on. So there will be some significance that will get attached to our h2. Are you getting this? So this term will only contribute, this hash function of h2 will only get a contribution if there is a collision. If there is no collision, then only base function h will keep on working in double hashing also. Okay, so let us take some examples so that it will be more clear for us. Okay, so if I take value now as 13, value as 13, so how it will look? It will be h dash of 13 comma 0, which is h of 13 plus I0, 0 multiplied by h2 of 13, okay, mod with 10, mod with 10, mod with 10. What will be answer for this, my dear students? 3. Because h of 13 is 3, this term will not give any contribution. Correct? This term will not give you any contribution. Is it understood, students? Any doubts?
Yes, sir.
Anyone is having any doubt? Okay, so this will come out to be, hash address is coming out to be 3. So 13 gets stored at 3. 13 gets stored at 3. Now, suppose I get next key value as 33. Suppose I give you next key value as 33. So what first thing we will solve? 33 comma 0. 33 comma 0. Correct? Which is nothing but h of 33 plus 0 into h2 of 33. What will be answer for this? As it is 0, H2 will not contribute. Answer I'll get as 3 only, which gives me a collision. Correct? Which gives me a collision. Right? So if it gives me collision, I'll increment value of I by 1. I'll increment the value of I by 1. So when I increment value of I by 1, it is H of 33 plus 1 multiplied by H2 of 33. 1 multiplied by H2 of 33 mod n. So what this will be? H of 33 is 3. What is H2 of 33? Can anyone tell me what is H2 of 33? What is H2 of 33?
3.
No.
33 mod 7.
Correct. See, my dear students, H2 is a different hash function. H2 is a different hash function. What is H2? As I told you, what is H2? It is K mod M. It is K mod M. What is M given in the problem? It is 7. So 33 mod 7. What is 33 mod 7? 5. 33 mod 7 is 5. So 5 multiplied by 1 is 5. 5 multiplied by 1 is 5. So this comes out to be 8 mod 10. So answer you get is 8. So you'll be storing 33 at 8. Is it understood how it came out to be 8? See, my dear students, the second hash function is based on M. Value of M is 7, not 10. So here also sometimes silly mistakes do happen. Okay, H2 is basically a different hash function. Here based on value of M. M is 7. So 33 mod 7 you should do for H2. For H you will do 33 mod 10. Is it clear, students? Double hashing technique. So if I take more key values also, you will be able to solve. I hope you have understood the philosophy now. So if some numericals are given to you as homework, you will be able to solve them. Okay. Is it understood?
Yes, sir.
So
Yes,
with
sir.
this,
Yes, sir.
we have completed the 3 types of open addressing techniques. If you remember, in collision resolution technique, I told you that there are 2 types. Yes, in the day before yesterday's lecture, right? So what were those 2 types? Open addressing, or we call it as open hashing also. This was one type, and second type was chaining, which is also called as closed hashing. In open addressing, there were linear probing, second was quadratic probing, and third one was double hashing, which we have completed up till now, all 3 types. Linear probing, the equation is h dash of k is equal to h of k plus I mod n. Quadratic probing equation is h dash of k comma I is h of k plus c1I plus c2I square mod n. And double hashing equation is h dash of k comma I is h of k plus I into h2 of k mod n, where h2 is a different hash function. We assume here it to be k mod m. Is it clear, my dear students? All these 3 types we have seen. Now let us discuss the second type of collision resolution technique, that is chaining. That is chaining. See, my dear students, whatever techniques we have seen in open addressing, all these techniques, what we see here is, if you see here, that if I get new key number, then I can able to store that new number because still the space is available over here. Third key value I can store, fourth key value I can store, fifth I can store, sixth, seventh, right? But here I have bounded my number of slots available. The moment I get 11th key value, for sure I am going to get a collision in that. correct? For sure I'm going to get collision for 11th key value. But after applying the collision resolution technique also, I will not be able to find the new value, because even if you apply that, all the spaces are occupied, you will not be able to store 11th key value in that case. So that becomes the limitation for open addressing scheme, because slots are kept fixed. We can say that this technique is static also for that matter, right? Because the slots are fixed. Are you getting the drawback of open addressing? All the three techniques, you take quadratic probing, you take linear probing. In all these techniques, we had that n, that is the number of slots available, as fixed. So if your given key values are within that limit, then even if you have a collision, you may be able to store, provided the number of key values are less than or equal to the number of slots available. The moment your number of key values becomes more than the slots available, then collision resolution technique will not be able to store, because there is no space available for that matter, right? Because your n is fixed in that case. Your n is fixed. Rather than n, the concept of n here is the number of space available in case of open addressing scheme. Let it be linear probing or quadratic probing or double hashing. All these three techniques will be having problem in that case. But that can be resolved in the chaining technique of collision resolution, which is more flexible, which is more dynamic in nature. So what is the phenomenon of chaining is it tries to fit as many key values, provided you have space in memory, but you are not restricting yourself to so-called slots available. There are slots, but again within each slot I will be able to store multiple elements. How we can do it? I'll show that with help of example. Now suppose I create the chaining hash function as k mod 10. Suppose I create chaining hash function h of k as k mod 10. Okay, so these are my 10 possible hash addresses. These are my 10 possible hash addresses. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, and finally this is 9. Okay, now my dear students, for each of these value, I will have an independent linked list attached to it. I will have an independent linked list. This is dynamic, I told. Chaining is a dynamic technique of collision resolution technique. Chaining is a dynamic way of collision resolution technique. So if it is dynamic, if it is flexible, something of linked list should come. If it is static, we had array over there, right? So here we have, if it is dynamic, we'll have a linked list over here. Okay, so now if I ask you to store 24, if I ask you to store 24 in this, so 24 mod 10, you will get answer as 4. You will get answer as 4. So on 4, now this 4 is nothing but, now this is nothing but your external reference pointer. You can assume these are your 10 external reference pointers. These are your 10 external reference pointers. So I'll be storing 24 in the linked list, which is my 5th linked list, which is indexed as 4. Okay, so here I'll be storing now 24. Here I'll be storing now 24. Did you understand, students? Now if I ask you to store 32, so what will be answer of 32 mod 10? Answer will be 2. So 32 will be stored here. It will go here. Are you getting this? Then again, if I ask you to store 55, suppose next key value is 55. Okay, next key value is 55. So what is answer of k mod n? 5. So it will be stored where? Here. 55 will be stored in the linked list which starts from 5. Now if next key value is suppose 22. So for 22, answer is 2. So here I'm having a dynamic data structure. So I can do a create at end, or you can do create at start also. Where you enter is not important, but you can create a chain now. So tomorrow if I ask you to search 22, how you will search 22? You will apply 22 mod 10. And in that linked list, you will do a traverse. So instead of traversing all linked list, you only traverse the linked list which is indexed from 2. So if collision is there, then only constant complexity will be compromised to some extent. But if there is no collision, again, you will get a constant complexity. Is this technique of chaining understood, students?
Yes, sir.
Is the concept understood, how chaining works? See, this chaining can be used like, suppose if I think of storing the students, okay, into bunch. So I can think of creating the hash function on the first letter of the surname. Okay, so I'll have suppose 20, I have 26 alphabets. So if I create 26, if I create 26 linked lists, right? So first linked list will be for A, second will be for B, third will be for C, and so on. 26th linked list will be for Z. I'm trying to give you different examples to make you understand this. Okay. So likewise, this will be A wala linked list, this will be B wala linked list, and so on. So how I design this linked list is my hash function basically. That is my hash function basically, right? Now if I ask you to store student names in this, see what will happen. There I will find some students with A as surname. I'll find with B. But imagine whether we have more number of, whether we have students with surname starting from X, with Q, with Z, with Y, with O. Very rare, right? These letters are very rare, which I'm writing. But what will happen to my linked list which starts from P when we are in Western Maharashtra, right? We all know the most common surname that we have in our region is Patil. Okay, so this is just for sake of example, nothing wrong with that surname. I do respect all the surnames. Okay, but just for example, see there are many students in our class whose surname is Patil, right? So that P wala linked list will be bulky in that case. There will be a lot of collisions. Are you getting this, right? So if I design my hash function in this way, that based on the first letter of surname, I will place all the students. So some linked list will be very bulky. I may have many students with surname starting with S. Okay. I may have with A also. These are very common letters. P, right? It depends. It depends on my data. It depends on my data. But very rare I'll find it with Z, Y, V, O, Q, right? So while designing the hash function, I have to be very uh, peculiar. Okay, and this hash function designing is based on a particular input. We all know this. If your input changes, a hash function which was perfect may get converted into good. And for a different input, that good hash function may turn worst also. So when I say a hash function is good or bad or perfect, it is with respect to a particular input. It is with respect to a particular input. So while designing this hash function, the developers, what they do, they try to analyze what kind of data is going to come into system. So based on that predictions, the hash function is effectively designed. Are you able to understand the applications of this hashing scheme? You are going to study more on hashing when you go in third year in databases. From here you are going to pick that, because in database, okay, in database we want to store and we want to fetch the data effectively, and that is nothing but searching. If I store proper, I will be able to fetch quickly, right, in the database also. So here these hashing schemes will be applied further. As far as our data structure course is concerned, we have this much only for our hashing in our curriculum. Okay, as a type of searching technique. So we have finished with our searching techniques today. So we have total 3 searching techniques in our curriculum. First one was linear search that we discussed, in which the input was random. Input was random, correct? Complexity was linear. Second technique was binary search. Here the input was organized, it was ordered, and that's why the complexity was logarithmic. And the third technique was hashing, in which input is more organized, because all this technique that we are applying is on storing. Input is more organized, and that's why the complexity is constant or near to constant in case of hashing. So hashing is the best, I would say, searching technique. Hashing is the best searching technique. If I compare linear, binary and hashing, if I compare only linear and binary, binary is best. Is it clear, students? So with this, we have completed with the searching techniques. In the next lecture, we are going to start with the second counterpart of this chapter, that is sorting techniques. You all know that the name of this chapter is searching and sorting techniques. So we had 3 searching techniques: linear search, binary search and hashing, which we have completed. In tomorrow's lecture, we are going to start with sorting techniques. So these sorting techniques, we have to discuss many sorts. I'll name them. We have to see bubble sort, selection sort, insertion sort, merge sort, quick sort, radix sort, heap sort. 7 sorting techniques we have to discuss. Searching, we had only 3 techniques. So 7 sorting techniques. Again, this is a big chapter. So 7 sorting techniques we have to discuss. Very important chapter, my dear students. See, day before yesterday, we had persistent interviews for your seniors, and in first week of this month, last week of previous month, we had Capgemini interviews. In those interviews, students were asked to explain the logic of these sorting and searching techniques in the interview. See how important this subject is. You can interact with your final year students, your seniors. Plan such sessions also on Microsoft Teams. So discuss, interact with them, ask what questions were asked. How did you answer those questions? Then you'll come to know why I am shouting at you people. This is a very important subject. So they were asked, you explain the logic of bubble sort. One student was asked binary search. See, the thing which you are learning today, you have to recall that when you reach in BTech final year. That time you have to take this numericals and you have to solve and you have to explain the algorithm to the interviewer. So please take this subject as the most important subject of your life. This is very, very, very important subject, not only for getting job, but when you go in industry and work on programming, data structures is our bread and butter. We cannot run away from data structures and algorithms. Okay, with this, we will be stopping for today's lecture. Okay, in tomorrow's lecture, I will be taking sorting techniques. Let me download the attendance, but before we do that, just hold on for a moment.